Alrighty, here we go. Finally, we get to some fun stuff. 7.5, Trigonometric Identities. Yeah, this is, you know what? Us math teachers love this stuff. You kiddies, not so much. Let me make you a little afraid. First of all these videos can be found at www.nkinfinity.com. My name is Mr. Krause. My partner in crime is Miss Vicky Newman. For today, you can call me Mr. Key. Trig Identities are sort of our proofs, which you all did not like so much in geometry, but these aren't bad. Stick around with me. I think you're going to be able to handle these. They're not that rough. Sometimes kids just can't think straight, but you'll be all right. That's why you're here. All right. Warm up. All right, so warm up. Let's go to the warm up. If pause this real quick, try to fill out some of these. Some of the things we've already talked about throughout the videos. But let's see. Cosecant goes with sine. Sine is opposite over hypotenuse, so this is hypotenuse over opposite. Secant is adjacent. Well, cosine is adjacent over hypotenuse, so this would be hypotenuse over adjacent. And then tangent is opposite over adjacent, so this is adjacent over opposite. They're also called reciprocal functions because cosecant is really just 1 over sine. Secant is just 1 over cosine. And cotangent is really 1 over tangent. Now this is sort of the useless one right here, the way it's written. Let's go over here and talk about some quotient identities. All right, tangent, another word for tangent, and I've already made reference to this earlier, we've said is y over x, right? Well, doesn't y in the unit circle represent sine? So this would be sine x, and x represents cosine, so this would be cosine x. And I probably shouldn't be using x with sine x and y, but I probably should be using theta or alpha or beta or gamma or just kidding. So if tangent is sine over cosine, then wouldn't that hold true that cotangent is cosine x over sine x? So those are some things you just have to kind of keep in the back of your head and understand and know and memorize. And I hate the word memorize. You just kind of got to get a feeling of it, and you got to kind of know it. It's not going to be given to you. It's not on your formula sheet. I mean, if you take a look at your formula sheet, you'll see in no place do they give you anything as far as trig. Nothing. There's no trig on here at all. That's it. That's all you get. So that's useless. So here's how we're going to work. Use the reciprocal and quotient identities to simplify the following expression. Now, what I want to tell you is if you can get things converted to sine and cosine, you're probably like well on your way to simplifying these things. So let's talk about cosecant. Cosecant is 1 over, remember we didn't match the C and S, so this is 1 over sine. Tangent, let's write it as sine over cosine. And cosine is just cosine. But write everything as a fraction, makes your life easier. Sine cancels with sine, cosine cancels with cosine, and my answer is 1. That's it. All right, now cosine squared x. Remember, that's like an x squared. So this is cosine squared x over 1 times 1 over cosine x. Remember, we didn't match the S and C on purpose because we don't like you. All over 1 over sine. All right, let's see what cancels. This 1 cosine cancels with, now careful, it just cancels with one of those. So what I'm left with is cosine x over sine x. Now, we're not simplified yet because I can simplify this to one trig function. And cosine over sine, if you look right up here, is cotangent x. Oh my God! Fractions and fractions and fractions and fractions and more fractions. I love it, I love it, I love it, I love it. All right, let's do this. So the numerator is sine x over 1 times 1 over cosine x. Now, normally I would transform this denominator into sine x over cosine x. I can do that. Why not? Change them all to sine and cosine. Well, the numerator is sine x over cosine x. And the denominator is sine x over cosine x. So this whole thing just simplifies to, 1. All right. I've done a couple. You try these on your own. Hit the pause button. See if you can come up with these 6. Give yourselves a few minutes. Try these on your own, and then see how you do. All right, I took a little pause. Now let's see how you did. Let's go through these. Sine is just sine over 1. Secant is 1 over cosine x. And cotangent is cosine x over sine x. I know it's 1 over tangent, but again, remember what I told you a few minutes ago. That's kind of the useless form of it. That doesn't help out very often. Normally you want to just convert everything to sine and cosine. Cosines cancel, sines cancel, I'm left with 1. All right, sine squared x over 1. Make sure everything's a fraction. 1 over cosine x. 1 over sine x. All right, let's see what we got. This sine cancels with this sine. It really leaves me in the numerator just sine, and then the denominator cosine. And I know that sine over cosine is really just tangent x. Now, you don't have to write it as sine over cosine, then write tangent x if you see it. All right, tangent is sine over cosine. Secant is 1 over cosine. And then this is just cosine over 1. These cancel. Really leaves me this, which is just tangent. So that's really just tangent x. Kind of a dumb problem. Why can't I blow that up? I like to blow things up. I don't mean like... All right, tangent is sine x over cosine x. And secant is 1 over cosine x. Now, we've talked already, kids. When you divide by a fraction, now I've said this a million times. I don't know if this is your first video of watching mine. I hope not. When you divide by a fraction, dividing by a fraction is the same as multiplying by the reciprocal. So instead of dividing by this, we're going to multiply by its reciprocal, which is cosine x over 1. Cosines cancel, and I'm left with sine x. All right, whoa, let's back up the crazy train. Let's see what we got here. 2 cosine x over 1 times 1 over cosine x minus sine x over cosine x times cosine x over sine x. All right. Cosines cancel. I'm left with 2 minus sines cancel. Cosines cancel. Now, that doesn't mean everything's gone, kids. It really just means it's 1. Remember, they cancel to make 1, so minus 1. So this answer is 1, but it's a really weird one. All right, here we go. 1 over sine x, that's the numerator, all over cosine x over sine x. Now, you can see if you don't have this stuff memorized and if you don't have this stuff committed to your memory, how difficult it's going to be. Instead of dividing by a fraction, we're going to multiply by the reciprocal. Gone, gone. And I'm left with 1 over cosine x. But you can't leave it like that. 1 over cosine x is really secant x. And that would be the simplest form. And I hope you did well with those. Flashback! I'll be right back. Okay, kids, I think I'm going to need my calculator, so I'm going to get that up and running. Let's talk about this unit circle. Now, it's called the unit circle because... I don't know why I can't... Oh, hitting the wrong button. It's called the unit circle because the radius is 1. So, and then we went through that long, drawn-out process. to show you that the x value is cosine and the y value is sine. So this is really cosine theta, and this is really sine theta. Well, what do I have here? I have a right triangle. I have a right triangle where my sides are cosine, sine, and 1. Well, one of the most famous things I can do with a right triangle, we've already done this in the last couple of days, is the Pythagorean Theorem. X squared, no, wait, hold on. How about a squared plus b squared equals c squared? Well, let's see what that looks like in this triangle. A squared, or the x's squared, is cosine squared theta plus sine squared theta. Notice how I'm writing it is equal to 1 squared. Well, wait a second. That means that cosine squared theta plus sine squared theta is equal to 1. And that is really, 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 really important trig function. What that means is, for you, I could take any value, I'm in degree mode, so I could take any value like 30, no, let's just take any weird value, 31.5 degrees. And let's store that into x. Shoot. Control var escape. Control var x. So I'm going to take some stupid value and I'm going to change it in there. Now, what I'm going to do is, in order to get this in there right for this, I have to do cosine of x squared plus, parentheses, the sine of x squared. And what do I get? 1. I could pick anything I want, 58.63125, and I'm going to, whatever that number is, I know I didn't type that in right, store that into x. 1. Negative 129.35789452134521345. I'm not hitting the right button. I'm going to store that into x. It doesn't matter what value I put in for x. Sine squared plus cosine squared always equals 1. Every single time. It is a trig identity that is incredibly important. Incredibly important. Now, from that, we're going to get 2 more identities. Woo, and these are the tricky ones, kids. So let's start with that simple idea that sine squared x plus cosine squared x equals 1. So the first thing we're going to do, and this is going to be weird, and you're not going to be expected to reproduce this, but you are going to be expected to understand this and understand what my final answer is and how this is going to be helpful. So we're going to divide both sides by sine of x, sine squared of x. Now, why would I do that? Well, it's legal to do that. I've divided the entire left side by sine squared x, and I'm dividing the right side by sine squared x. Now, why would I do that? Well, I'm doing that so that I can come up with a new trig identity that might help me later on. This is equal to 1 plus, what is cosine squared over sine squared? Oh yeah, that's cotangent squared theta is equal to 1 over sine squared, cosecant squared theta. Say what? So what you're telling me is cotangent squared theta plus 1 is really equal to cosecant squared theta. This is part about what math, this is one of the things that mathematics is all about. I can understand one idea. Can I manipulate it? Can I change it by doing a mathematically legal thing like dividing by sine squared and come up with something totally new? I mean, I started up here with sines, cosines, and 1s. I don't have any of that down here, but I've created a new trig identity that needs to go in the brain book. So it's now if you remember cosine squared plus sine squared equals 1, And then you can just divide. You can recreate this if you want. I like to say, in this case, the C's stick together. So CC, cotangent plus 1 equals cosecant. Well, what about identity number 3? This was identity 1. This was 2. And now we're going to go to 3. But 3, again, starts with sine squared theta plus cosine squared theta equals 1. This time we're going to divide by, you guessed it, cosine squared theta. I don't think you guessed it. I have, well, maybe there's a couple of you that guessed it. But that's another legal move. Why would I do that? Because that's what I want. I mean, I could have divided by cotangent, but it doesn't really help me out at all. This is going to help me out. Why? Well, what is sine squared over cosine squared? Oh, that's tangent squared theta plus this is just 1 equals, and 1 over cosine squared is secant squared theta. And there it is. There is my third trig identity. So those are ones that you have to commit to memory. The weird ones, I like to call these the weird ones. Cosine squared plus sine squared equals 1 is just like Pythagorean Theorem for trig students or for algebra 2 students. It is, okay, in 7th grade you learned the Pythagorean Theorem. You thought we were the coolest thing since sliced bread. You're like, oh, mom, a squared plus b squared equals c squared. I'm so cool. Well, now we're up 4 years later. Sorry about the spitting. I'm excited. 4 years later, we're now at the trig stuff, the algebra 2 trig stuff, the big boy, big girl stuff. And now you got to remember these new trig identities. Well, cosine squared plus sine squared equals 1 is now the big boy trig identity that all trig students, all algebra 2 students and above should know and commit to memory. In 5 years from now, if you're still taking math, and they say, what's sine squared plus cosine squared? You say, that's 1. I know that. Everybody knows that. It's going to be just like a squared plus b squared equals c squared. It's got to be committed to memory. Okay, it's just one of those things. Now, from that, I can get these. I can derive what's called derive these. I can make these. In mathematics, it's called deriving the formula. You're doing something. You're manipulating something so as to arrive at a new formula or new identity or new equation. You're deriving it. All right, so how do you remember these? Well, I remember these ones, the C's stick together, and this one, alphabetically, they're close. They make T and S. So, I don't know. So let's see how we're going to simplify radical expressions. I'm going to pause and I'll be right back. All right, let's go through these. How am I going to do these? Well, a few minutes ago you just said turn everything to cosine and sine. So I know that cotangent is cosine squared x over sine squared x. And then I'm going to add 1. But I can't, in order to add fractions, I have to have a common denominator. So the common denominator will be sine squared x. So in order to make 1, wouldn't the numerator have to be sine squared x? Sure. So now that I have the base is the same, or the denominator is the same, I keep them as sine squared x. The numerator is cosine squared x plus sine squared x. And then you just ranted and raved about the fact that everybody should know that cosine squared x plus sine squared x is really 1. So this is 1 over sine squared x. But 1 over sine squared x is really cosecant squared x. Now, that's the mathematical proof to get there. However, trig identities are things you're just allowed to use. So, just like tangent, I don't have to prove to you that tangent of x is equal to sine x over cosine x. It's a given. It's something you have in your brain. Just like a squared plus b squared is equal to c squared, I don't have to go through that whole long proof for that. It just is what it is. Well, I've already proven to you that cotangent squared x plus 1 is cosecant squared x, so you don't have to prove it to me. There it is. It's done. Boom. Well then, okay, then let's look at this problem. 1 minus secant squared x. What did you say secant squared x was earlier? Didn't we have something for secant squared x? I think we do. Oh. Secant squared x is really tangent squared plus 1. Okay. So let's see how we're going to do this one. This is 1 minus. Now, I'm going to replace this with a binomial, so in order to do so, I got to put it in parentheses. We just said that secant squared x is really tangent squared x plus 1. All right, so let's distribute the negative. I get 1 minus tangent squared x minus 1. The minus 1's cancel, and I'm left with negative tangent squared x. That's some crazy. So let's see what we got here. What did I tell you cotangent squared x was equal to? Cosecant, well, that's kind of useless. So here's another way of writing this. I can write this as cotangent squared x over cosine x, squared x, minus cosine squared x over cosine squared x. Sometimes you just got to play with these just to see what the best way to do this. This is just 1. That's kind of nice. This is kind of a disaster. So how about we change this to cosine squared x over sine squared x all over cosine squared x over 1. If I divide, I really multiply by the reciprocal. So I'm going to multiply by 1 over cosine squared x. The cosine squared x's cancel, and I'm left with 1 over sine squared x minus 1. Well, what is 1 over sine squared x? Isn't that cosecant squared x? Now, what is cosecant squared x? Isn't cosecant squared x really just cotangent squared x plus 1? And then minus 1? So these cancel, and I end up with cotangent squared x is my answer. All right, that's one way to do the problem. Let's try something else. Here's another way to do the problem. I can write cotangent squared as cosine squared x over sine squared x minus cosine squared x over 1 all over cosine squared x over 1. Well, that's kind of useless. Let me change this so that I have a common denominator. My common denominator will be sine squared x. So if I add it to the bottom, I got to add it to the top. So my numerator becomes cosine squared x minus cosine squared x sine squared x all over sine squared x all over cosine squared x over 1. Holy crap. So let's see. Can I take out a 1? Or I can take out a cosine squared x. And I'm left with 1 minus sine. Oh, this is much more difficult than we thought. So I think the other way was easier. Sometimes they're just harder. Sometimes they're just much more difficult. I think the way I started that problem was the easier way. So don't worry about that second way. We'll just ignore that. All right, so let me pause, and then we're going to come back to verifying. I talked to you about what verifying is all about. All right, verifying is like proofs. If you want to, you can think of this as prove. Prove the identity that sine cotangent equals cosine. In order to do that, you'll notice what I said here. Change one side and only one side to make it look like the other side. So you're only allowed to use or manipulate one side. So what you want to do often is just grab the more complicated side. Whichever of the two sides is more complicated, use that side. So on this side, the left side's more complicated. So, and then again, we'll try to convert it. So before I didn't have an equal sign. Now I have an equal sign. Now it's like this. Before I said simplify, you're like, I don't know, maybe I got it right. Maybe I didn't. The cool thing about these is You already know what the answer is. I know that when I'm done, I've got to make the left side look like cosine x. So before I might have said, hey, simplify this, you're like, I wonder what it's going to be. Now it's kind of cool. You know it's going to be cosine x. So if you don't get cosine x when you simplify the left side, keep working on it. Keep plugging away. I'm going to teach you this word over and over. It's called perseverance. Perseverance means getting through stuff that's really, really hard and never quitting. Never let anything stand in your way. It is a lifelong lesson. Those who persevere will make it in life. Those who don't, you're going to be hopefully winning the lottery, or you're going to be going like this your whole life going, what happened? What happened? What happened? So persevere. Do not quit. Don't let anything stand in your way, ever. Ever. These aren't that easy, but you can do it. Once you get it, you're like, whoa, that wasn't bad. That wasn't bad. Sine is just sine over 1. Cosine is, or cotangent is cosine x over sine x. And again, I've got to make this thing look like cosine x. Don't mess with the right side. Oh, the sine x's cancel. Cosine x equals cosine x. That's it. I did it. Let's go. I did it like this. Did it. Okay. Left side's more complicated. But I know when I'm done with the left side, it better be cotangent. And by the way, you can't just go cotangent x equals cotangent x. You're like, yes, I did it. The teacher will never know that all this stuff is a bunch of hogwash. Oh, yeah, we will. Because we look for it. So don't do it. You know it's going to be cotangent x. I can even write at the bottom here, cotangent x equals cotangent x. Catching. I just got to figure out what these steps are to get to that. All right, convert them. Secant, cosecant is 1 over sine x. Secant is 1 over cosine x. And I still want to make this look like cotangent, excuse me. Cotangent x. All right, if I divide, I multiply by the reciprocal. I end up with, I'm going to multiply by cosine x over 1. So I end up with cosine x over sine x. Does that equal cotangent x? Now, I will warn you, this is not good enough. Not good enough. You must write this next statement. Because I know that you know that cosine over sine is cotangent. But unless you tell me, the person grading your test doesn't know. And remember, in New York State, teachers are not allowed to grade their own students. Even though I know you're smart and you realize cosine over sine is cotangent, you're done. It's right. No, it's not good enough. You have to write that final step. Left side's more complicated. I know when I'm gone, I'm going to have tan x equals tan x. I just have to get there. All right. 1 over cosine x times sine x over 1. This is sine x over cosine x. And isn't sine over cosine really just tangent? There I am. I'm done. Now, it's going to be in your best interest to pause the videos from now on and just try these on your own. They get more complicated. This one looks like it might be a little more complicated. Stop. You know you're right at the end when you have cosecant x equals cosecant x. So pause that video, try it, and then if you get frustrated, that's frustrated and flustered at the same time I get. All right, let's try it. Cotangent x. Oh, that's cosine x over sine x divided by cosine x. And I make everything a fraction. I know you hate fractions, but make everything a fraction. Because that one rule of multiplying by the reciprocal is going to help out. So we're going to multiply by the reciprocal, which is 1 over cosine x. Man, that is one fat black marker right there. That's not going to work. So this cosine cancels with this cosine. It leaves me 1 over sine x equals cosecant x. Well, 1 over sine is cosecant, so I'm done. Again, pause the video. Try this one on your own. This one's not bad. The next page is going to get a little ugly. Cosine x over 1 times 1 over sine x. Does that equal cotangent x? Well, this is cosine x over sine x. And yes, you need to show these steps. You need to show your work. What is cosine x over sine x? Oh yeah, that's cotangent x, and that equals cotangent x. Ka-ching! This time the right side's more complicated, so I'm not going to mess with the left side. Pause it. Pause the video. Try it on your own. No, seriously, pause it. I'm going to do this one two different ways. All right. The first way I'm going to do it's the long way. Cosine squared x over sine squared x times sine x over cosine x. Believe it or not, this is the slow way. Cosine with 1, sine with 1. So I'm left with cosine x over sine x, which is really just cotangent x equals cotangent x. Now that's the slow way. Let me do it the fast way. I could go back to the fact that cotangent is really 1 over tangent. So this is really 1 over tangent squared times tan x over 1. This tan x cancels with this tan x. I end up with 1 over tangent x. But 1 over tangent x is really cotangent x. Either way, it doesn't matter. We arrived at the solution. Pause the video. Try this one on your own. This one's easy. You can do it. You can do it. It's not bad. All right, I'm glad you're back. Let's see how you did. So sine x over cosine x times cosine x over 1. Does this equal sine x? Yes. Sine x equals sine x. Perseverance, kids. That one was simple. This one looks a little uglier. No, it's not. It's easy. This is sine x over 1 times 1 over sine squared x. Does that equal cosecant x? Well, this one cancels with one of these. It leaves me 1 over sine x. Does that equal cosecant x? You can't stop here. You got to go one more step and give me that final step that cosecant x equals cosecant x. Ka-chang. And then you got to go ka-chang at the end. All right, kids. Now it's getting ugly. So let me pause. Now, by ugly, I mean really super cool and fun. Okay, I'm going to do this two different ways. I'll do this the hard way, and then I'm going to do it the easy way to show that even though you don't start out the right way, or maybe you didn't start out the right way, but you started and you didn't quit, you can still arrive at the same solution. So what I'm going to do is I'm going to, I don't know, let's mess with the right side. I'm going to leave the left side alone. Sine of, I'm not sure what that symbol is. I'm going to call it theta. I got to try to make it. What is this symbol? That, minus 1 over cosine of, that's a symbol. I'll figure it out. It may be, I'm not sure what it is. So tangent is, by the way, I'm doing this the wrong way the first time. Sine over cosine minus 1 over cosine. Oh, no, I'm not. I'm doing this the right way. Man, I thought I was doing it the hard way. Oh, I want to go back to theta so bad. I hope the next one's got x. Good. Is equal to, well, now that I have the common denominator, I keep the denominator and I add the numerators, or just do the numerator sign. Minus 1. Well, there we go. Done. That wasn't so bad. Let me do it another way, just to show you it makes no difference which way I tackle it. That turned out to be pretty easy. This one I can make as sine. I can just break it up. Sine over cosine minus 1 over cosine. You're allowed to break that up. Does that equal tangent? I got to get off this problem because this thing's driving me crazy. Secant blob. Well, what is sine over cosine? Oh, yeah, that's tangent of whatever that thing is. Minus, what is 1 over cosine? Oh, yeah, that's secant of whatever that thing is. Does that equal? And I'm just going to say yes, it equals, because I'm sick of drawing those things. All right, what the heck is this? I'm going to say the right side looks more complicated, so let's take care of the right side. Let's leave this as cotangent squared x. So we're going to double distribute. Now, these are conjugates, which means the middles are going to drop out, but some of you don't understand that, so let me draw it for you. This is cosecant squared x plus cosecant x minus, so that's plus cosecant x minus cosecant x minus 1. Well, these canceled. So I end up with is, does cotangent squared x equal cosecant squared x minus 1? Well, I don't really have one for what cotangent squared x is, but I know that cosecant, cotangent. I know that cosecant squared x is really cotangent squared x plus 1 minus 1. Okay, the 1's cancel and I end up with cotangent squared x equals cotangent squared x. Okay, 2 left. I don't know. I think maybe the left side looks more complicated, so let's mess with the left side by distributing. So I end up with cotangent x minus cotangent x sine x. Does that equal cotangent x minus cosine x? Well, the good news is I already have cotangent x. That's nice. Minus, this is cosine x. See, this already matches this. So as long as this thing matches this thing, we're good. So let's try messing with that. Cotangent x is cosine x over sine x times sine x over 1. Sine x cancel. Oh, I want to prove, does this equal cotangent x minus cosine x? The sines cancel, so I end up with cotangent x minus cosine x. Yeah. Yay. All right, last one, kids. Try this on your own. Play around with it. Don't watch me. Do it on your own. Oh, you're back? Good. Well, the first thing I'm going to do is not say this is cosine squared and sine squared. I'm going to double distribute. So let me write it out for all of you people that need it written out. Does it equal 1 minus 2 sine x cosine x? All right, so, oops, sorry. Let's double distribute this baby. That's cosine squared x. This is minus cosine x sine x. And this, oops, this shouldn't be a squared here. This is minus cosine x sine x. And then this is negative sine x times negative sine x, which is plus sine squared x. Does it equal 1 minus 2 sine x cosine x? Whew. Well, this is cosine squared x. And this is plus sine squared x. I'm going to put those two together. You'll see why in a minute. And then minus, these are actually the same terms. Minus cosine x minus cosine x is really minus 2 cosine x sine x. Does that equal 1 minus 2 sine x cosine x? We'll see. We're at our final step. What is this? Oh, that's just 1 minus. Now, I got to make these look the same. And since multiplication is commutative, it makes no difference what way I order. 3 times 4 is the same as 4 times 3. So it makes no difference what order I multiply in. So I'm going to change the order of this to make it 2 sine x cosine x. I just changed the order. And I can do that because multiplication is commutative. Well, wait a second. That's the right side. I did it. That, kids, if you can get through this stuff, is the definition of perseverance. Do you have the wherewithal? Do you have the guts? Do you have the thing that's going to make you successful to get through these difficult problems? Yeah, look at that crap. There's almost no numbers in that entire thing except for maybe that 2 over there. Yeah, I got a 2 here. Oh, and I got a 1 here. But wait, that came from things that weren't even numbers. Okay, this is where you start separating. Can you get through weird stuff to get to the right solution, to get to the understanding of the mathematics? Because that's what's going to turn you successful when you start to get into the problems that are going to make you some money someday. All right, kids, hit the subscribe button, hit the like button, rewatch it if you didn't understand it, and try these on your own. Persevere. It's the most important single lesson in your life. Persevere. Do not let anyone stand in your way. I don't care who they are or what math problem it is. Don't let anybody stand in your way. All right, kids? This is the definition of success in life. All right, kids. Catch you on the flip side. Bye.